This is a short video just to show you how you go about downloading LiDAR data and then mosaicing all the tiles that you get into a single DTM for your area of interest. So the first thing that you need to do is to go to the DEFRA survey data download page. You can just search for it in Google. So it's this hit here. So we'll select that. And that takes you to a map of the whole of the UK. So at this point you can then zoom into your area of interest. So just for a demonstration, I'm going to look at the area below Brotherswater at the head of Ullswater. You've got the option to upload a zip shapefile. So you can upload your catchment outline, but it's a bit of a pain because it has to be quite a simplified one, so you might have to play around with the shapefile before you upload it. I think it's a maximum of 1,000 nodes that you're allowed on the shapefile. Or if you know roughly what area you're interested in, the other thing that you can do that's quite a bit faster is to just draw a basic polygon of the area that you know that you're interested in. So once I've drawn my polygon, this arrow appears and that says get available tiles. So you can click on that button. And it'll take its time to load. But what it does once it's finished loading is to give you a list of all the available data for that chosen location. So there will be the surface model. Yeah, here we are. So the surface model, which contains all of the trees and houses and things like that. The terrain model, once those features have been stripped away. Got the point cloud, the bare tiles, and you've also got an option to download the aerial photography for this area as well. So what we want is the Composite Dtm, so we'll select that. By default it just gives you the most recent data, which is great. In resolution we can see that for this area we've got 1 meter resolution available as well as 2 meter. So the 1 meter is higher resolution and will give us a better chance at seeing some of the features that we're interested in. So we will go ahead and choose the 1 meter resolution in that option. So you click the available tile and that will start a zipped folder download. Once that's finished, we can open up the folder. It's zipped at the moment, which means that we won't be able to access it in Arcgis. So we need to extract it first. You can just leave it in the downloads for the moment because we're going to come back and delete these later once we've mosaiced all of our tiles together. So you can leave those there for the time being. So in order to start stitching all of these individual files together, we need to open up Arcgis. So I'm doing this in Arc Pro, but you can do it as easily in desktop. It's just very slightly different. Just for the purposes of demonstration, we're going to set up a completely new project to do this, so you can see the process. So under New, if you click Blank Templates Map, and that will ask you to create a new project. So we'll just name this LiDAR test, and it's created it in the default location. You can obviously save it wherever is appropriate for you. Now, by doing that, if you look in the catalogue pane, it will have automatically created a geodatabase for you. And that's great because that's where we're going to be saving all of our data. So in order to bring all those tiles into your new project, what you need to do is to search for the mosaic tool in the geoprocessing window. You get two main hits for mosaic. The first one is to merge lots of rasters into an existing dataset, but what we want to do is to create a completely new dataset for the DTM for our area. So if you go and select that second option, mosaic to new raster. So if you go to your downloads folder, and here's our extracted folder with all the tiles in it. So what you want to do is to select all of those. The output location you want to choose as the geodatabase that you just selected. We'll call it something like DTM 1 meter resolution, and the name of the tile was NY41SW. Okay, we'll also need to create a spatial reference for our raster. So we're going to save it in a projected coordinate system, national grids, Europe, and then we choose British National Grid here. Now the pixel type, this has caught me out before. If you leave it as the default for 8-bit unsigned, it will convert all of your nice detailed LiDAR information into whole numbers, which means that you start to get these big steps in the data instead of having all of the decimal points for the height. So what you need to do here is to change that default to 64-bit, and that will maintain all the decimal points in your data and make sure that you don't lose any of the detail. Cell size is to do with the resolution of our data set. So we know that we're on a 1 meter resolution. So if you put 1 in there. Number of bands, for this type of data we've only got 1 band, and we can leave these defaults as they are. Just checking the environments. Okay, so we're all set up to create our new DTM from all the input tiles. So if you click run, it might take a couple of minutes depending on your machine. Okay, so the tool's finished processing and it's mosaicked all of our individual tiles together to create the DTM covering our whole area of interest. So if we take it off, you can see that it covers this area just downstream of Brothers Water that I was interested in. So we pop that back on, and we can change the symbology to something a little bit more suitable to elevation. And one of the other things that you can do to make the features in this data really stand out is to create a hillshade layer. And if you input the DTM in here, and call it something sensible, this looks at shadows essentially, based on the DTM. But once we run it, you can have a look, and it really helps to show up some of the features in the LiDAR data. These inputs here are to do with the sort of elevation and location of the light source, so you can play around with those, and that might get you a better hillshade result. But for the moment, we're going to just leave those as the default. So if you run that, okay, so this is the hillshade output, which shows you essentially a little bit more detail of all the features in the LiDAR. Now what you can do is to drag that underneath your DTM, and if you change the transparency of your DTM to something like 30%, then the hillshade layer underneath starts to show through. And if you zoom in, you can start to see a lot of detail with the LiDAR that you weren't necessarily able to see in your original symbology. So it's a really nice way of making those features really stand out.